Here we go. So here is question 36, loading up, loading up, loading up. There it is. Okay. So from last time, can you tell me what the exponent of b is that is not written?
1.
It's 1. And it's good to write that in. So there's this, it's kind of like the distributive property. You may have even said that. You take this 5 and you distribute it to both of these if you're multiplying.
Okay.
So that's a to the 30, b to the 5th. You can think of it as distributive.
Okay.
And let's see here. Did you specify which ones we're going to work on or just
We're doing the evens.
even? So we're going to just
So
go
16 through 82.
36 through 80 even?
No, 16 through 82.
Okay,
Even.
but you want us to start at 36?
Yes, please.
Okay, and we're going 38.
Yes.
All right, so here's 38 here. Yeah, way better doing it this way. Okay, got 9t to the power of 8 squared. Okay, so just like the previous problem, there's an exponent above 9. What is that exponent?
1.
It's 1. It's not written because it looked weird, to every time have a 1, but it matters here because you're going to distribute that 2 to both. Okay, so it's 9 squared t to the 16th power.
Okay.
And 9 squared, can you tell me that?
9 squared is 81.
81. So it's 81 t to the 16th. That's your final answer.
Okay.
40 is c over d to the 9th. So this distributive property works for both fractions and for multiplication. So you still give that 4 to both the top exponent and the bottom exponent.
Okay.
So tell me what the result would be.
So C would be 4.
C to the 4th, good.
And then D would be 24.
You're multiplying. It's 4 times 9.
Oh, sorry about that. $36.
36, good. Any questions on that?
No, thank you.
Okay, 42 here. 5t to the 8th over 3m cubed. So really good to draw all the exponents in, especially as a first time seeing this really does make a difference here. So it's 3 times 8, 3 times 1, 3 times 3, and 3 times that 1 there. So your focus is just on the exponents, like it's 5 to the power of 3, t to the 24th, 3 to the power of 3, m to the power of 9. Don't try to simplify it until you've done this step.
Okay.
Okay, now 5 cubed, you have to know that that value, or if you've got a calculator, go ahead and do that. I'm gonna have you do those because familiarity will help you get more comfortable with this. What is 5 to the power of 3, or 5 times 5 times 5?
125.
125. T to the 24th power. And then what is 3 to the power of 3, or 3 times 3 times 3?
27.
27. M to the 9th. Okay. All right. I guess we're moving on to 44. 1 to the power of 0. Anything to the 0 power is always 1.
1.
Okay, but it's just whatever is to the power of 0. So in 46, it's in parentheses, minus 9s. Like it could go on. It could be a bunch of things. If it's to the power of 0, everything inside the parentheses turns into 1.
Yes.
Okay. 48. 75 times b to the 0. Now, the way I've written this, I've separated them because 75 really has an exponent of 1. It does not have anything to do with the 0.
Yes.
B to the 0 is 1. This right here, this b to the 0 becomes 1, but it's 75 times the 1.
Okay.
So it's just 75. It's only the part that's to the power of 0 that becomes 1.
Okay. Okay, thank you.
And then 50 minus 9 mn to the 0. Okay. So notice the way I've written it. I've not tried to squeeze the letters together. It's really minus 9 to the power of 1, m to the power of 1, and n to the power of 0.
Okay.
It's just the part. Sorry about that. Just the
Okay.
part. Why did that happen again? That is, it's just this that becomes 1.
Yes.
Okay, so it's minus 9 times n times 1. So minus 9 times m times 1. Anything times 1 is itself. So it just becomes the original thing, minus 9m.
Okay.
So real quick, just because we have plenty of time here, can you tell me what 6m to the 0 n would equal?
That would equal 6n.
Yes, good. Okay. All right, so 52. Okay, yeah, finally we're up to these. These are really, this is where it kind of starts getting unclear. 3 to the minus 4 power. Okay, so I'm gonna just show you, I'm gonna show you something here. Hopefully you like it.
Okay.
3 is really 3 divided by 1. Do you agree with that?
Yes.
Okay, so 3 divided by 1 is still 3 to the negative 4 power. The negative causes what's inside parentheses to flip.
Okay.
So notice the difference between what I've got here on the left and the right is that it's flipped inside parentheses. Negative 4 went to positive 4. Okay. Is
Okay.
that okay? Now these have
Yes.
exponents, right? 1 and 1.
Yes.
You can distribute that 4 to both of them.
Okay.
So it becomes 1 to the power of 4 over 3 to the power of 4. 1
Okay.
to any power is 1. This is another rule to remember. Just like anything to the 0 power is 1.
Okay.
Okay. So the numerator becomes just 1. Do you see that?
Yes.
Now here, like in class, what they will show you is they'll show you this that is circled in blue to this circled in blue. But there's actually this progression that we just went through that I want you to see, because maybe it will mean something. Basically, you have to recognize that the exponent being negative means the thing that is the base, the 3, goes to the bottom.
Okay. That made sense.
Does that make sense? Now, what is 3
Yes.
to the power of 4?
3 to the power of 4 is 81.
So this is 1 over 81. Is that so? So if you got this down, like you're allowed to go from this top to this bottom. You don't have to do all these intermediate steps,
Okay.
but you have to understand like what is going on here so that so you understand it's just the 3 becomes 1/3 because 3 is really 3 over 1. You flip it and so on. So let me give you one like this. Okay.
Okay.
5 to the minus 2 power. I want you to simplify this. It's just like the last problem, just different numbers. Whenever, I mean, don't just go to the calculator. That's not productive
Yeah.
here, but
So
give that a try.
what you want to do is you want to make the -2 positive. So you make it 1 over, or 1 to the power of 2, and then 5 to the power of 2.
Good.
And then that'd be 1 over 25.
Right. So a lot of students go right to this line right here. And I
That's what we just done in class. We just
and
make
that's
it a
true
one.
as long as because but sometimes something gets lost in the mix. Okay.
Okay.
So here, like, and we're gonna build into doing these problems. It's really important that we do a few. What is 2/3 to the power of -3? Okay, so this is where what I just said really matters because you flip what's
Yeah,
inside.
you flip.
So it's 3/2 to the power of 3. And then you give each exponent that 3. So it becomes 3 to the power of 3 over 2 to the power of 3.
Okay.
So 27/8. I want you to get this in your notes or look it over real hard because I want to give you one just like it to try different numbers.
Okay. Okay, I got it.
Got it? Okay. All right, so let's go 4/3 to the power of -2. I just want your final answer. You're welcome to ask me some questions along the way if you need to, but
Okay.
take a look at that and let me know
So
what you come up with.
you want to make it 4 to the power of 2 over 3 to the power of 2. And then you flip the 2, which makes it 3 to the power of 2 over 4 to the power of 2. And then you simplify that and you get 9 over 16.
Yes. Yes. Now I heard something I didn't quite like, but then I heard this
Oh, yeah, I just flipped it
and
over.
then 3 squared over 4 squared. Yeah. I think
Okay.
last time we also had this discussion like if you have x to the -7 over like y to the -3, you move the positions of them so it became like y cubed over x to the 7th. Does that look familiar to you?
Yeah.
Okay. That's kind of related. All right.
Okay.
Okay, now we're going to do 56. We're going to come back to 54. We're going to do 56 first. Sometimes I do this because it really does matter the order here when we're learning this for the first time. What is the exponent of 12?
1.
It's 1. So this y to the -5, like, and I can do this very easily because I can just grab it. Like, it's not part of the 12. Like, you need to deal with this over here on the right. So
Okay.
it's just like 3 to the -4th or 5 to the -2, but it's got a letter this time. I want you to simplify just this first. Forget about the 12, just this.
Okay. So I got 1 over y to the 5th power.
That's right. That's right. So this is 12 times 1 over y to the 5th power. How can you write 12 as a fraction?
12 over 1.
12 over 1. So you multiply the tops and then you multiply the bottoms.
So you get 12 over y to the 5th.
Yes.
Okay.
Okay. So just to see if you got that down, let's do -6x to the -3. Can you simplify that for me, please?
Yeah. So would you keep the -6 the same?
Yes.
Okay.
That's what I was hoping you would ask.
Okay. And then, so you get -6 over x to the 3rd power.
Good. Really good. Okay.
Okay.
We're gonna do 58 next. We will do 54.
Okay.
Negative w to the -2 power. So I do this a lot with more advanced math classes, but there's literally a rewrite step in almost every math problem you're doing, and that's what we need to do here. We need to rewrite this so that it's clear. It's really -1 times w to the -2.
Okay.
Okay, like again and again, what I have the ability to do is I can grab this and say deal with this. Deal with this w to the -2. Ignore the negative.
Okay.
So go ahead and rewrite this for me, please.
That'd be 1 over W2.
So this is now -1 times 1 over w squared, like that.
Yes.
So -1 is really -1 over 1.
Hmm.
Okay. And then it's -1 times 1 is -1 over w squared.
Okay.
Really want you to, I mean, if you can, just look at it one more time, because like the way it's written, what they want, it's deceptive because students will do something that we haven't talked about. I don't even want to bring up here, but I really want you to see that it's a separate, negative is really -1. It's a separate quantity altogether.
Okay. So you weren't even worried about the exponent being negative. You just
That's
put
right.
a
You
1
just,
over it.
right, because it's once that, then that's why we did this step here where I was giving you so much space, so
Yeah.
you would not, you just, oh well, that comes along, just comes along for the ride.
Okay, that makes sense. Yeah.
All right, now I don't like 54, but we got to do it. It's for homework here. Parentheses -4, -3 power. All right, now -4 in parentheses is really the following. It's really -1 times 4 to the power of -3.
Okay.
Okay, now both of these numbers have
1.
exponents. Yeah. So when you distribute that -3 to both of them, it's really -1 to the -3 power, 4 to the -3 power. Is
Okay.
that okay so far?
Yes.
All right, now I want you to deal with this one first, the 4 to the -3. Tell
So
me
you want to
what that,
make that 1 over 4 cubed.
that's right. And what does that become?
1 over 4 cubed.
Yes, what is
Oh,
4
you
to,
mean what is 4 cubed? Oh, okay,
what,
my bad.
so your instructor, when it's a number to a power, they expect it as long as it's reasonable. Like 4 to the 3rd is reasonable, but 4 to the 10th is not. So you have to, you know,
Okay.
you have to be like, all right, I
So
know
it'd
that
be,
one. Good,
okay, so it'd be 1 over 64.
good.
Okay.
Okay. Now this one is really awkward. It's sometimes better to rewrite it this way: -1 to the power of -3.
Okay.
And what that means is -1 times -1 times -1, but it's on the bottom.
Okay.
So it's like, okay, well, what is that?
Okay.
What does that become? Do you have an answer for me on this?
-1.
Yes. Okay. So it's -1 times 1 over 64, which becomes -1 over 64. All right. So do you remember earlier how I said 1 to any power is 1?
Yes.
-1 to an even power and -1 to an odd power, we're going to talk about right now. So
Okay.
is -3 odd or even, or you're not sure?
It's odd.
It's odd. So -1 to an odd power is always -1. -1 to an even power is always 1. This might be worth writing down, looking at, staring at. Okay, now I
Okay. Thank
promise
you.
I promise we're gonna move a little faster here, but that was a really important discussion that we had that I think will make a difference here in these future problems.
Yeah.
Okay, so we're gonna move on to 60. Okay, are the bases the same?
Yes.
Base is the same. When you're multiplying, you add the exponents. So you add -9 plus -2. they're individual numbers and you add them together. -9 plus -2. That is
So that'd be,
-11.
yes.
And then from the discussion we just had, how do we rewrite this?
Um, oh, 1 over n to the 11th power.
Yes,
Okay.
very good. Very good.
I didn't see it was a negative at first.
Yeah, you're like, why are we don't need to rewrite it. Yeah, no negative exponents.
Yes.
Have you asked your teacher why?
No, I just kind of went with it. Well, how
Okay.
can
I don't know. I think it's a fair question to ask. Why? You might get an answer like, well, why do we drive on the right side of the road?
Yeah,
And
that's
I
true.
and I don't know. I couldn't tell you. So, all right, new question here. 62 -t to squared times -5. What did I tell you to do with this negative? How should you rewrite this negative?
-1.
Yeah, so it's really -1 times t squared to the -5 power. And the exponent of -1 is 1. So you're going to use the distributive property.
Okay.
-1 to the -5 times t to the -10. And you know enough to try to work out the rest of the problem from here. So please ask if you have questions, but let me know what you come up with.
So I got -1 because -1 over -1 just equals
Good.
-1. So
-1 to an odd
-1,
power is always -1. Sorry, go ahead. Yep.
yeah, times 1 over t to the 10th power.
Okay. So if you left it like this, I don't know, it's like when you put your dish in the sink, but you don't put it in the dishwasher, you don't clean it. It's like it's done, but it's not done, you know. You can rewrite this as -1 over t to the 10th power.
Yes.
That's what they want. That's truly what they want.
Okay.
Okay. All right. So let's go to 64. 64 has a rewrite step in it. I'm going to rewrite it as 3 times 1 over b to the -5 power. So it's kind of basically me undoing what I just said. I said, like, don't leave it this way, but we're going to do something to it.
Okay.
Okay. So if b to the -5 is 1 over b to the 5th, we covered this last time. 1 over b to the -5 is b to the 5th over 1. Basically, it switches positions. Do you see that? The negative
Yeah.
comes to the bottom. So this right here, this 1 over b to the -5 becomes just b to the 5.
So basically, from the other problem, you just switch, you flip them, but you make the 5 positive.
Yes.
Okay.
Well said. Yeah.
And then
So your answer is
you,
just 3 times b to the 5th. You squeeze
okay.
them back together.
I thought you still made it a fraction.
No, well, no, there's no fraction because the b to the 5th is in the numerator now. If it were a fraction, I'd
Oh,
write it.
that's true. You're right. Okay.
And that's good. That's a good question to ask because this is all very unclear the first time you see it.
Okay.
Okay. So there's nothing in the denominator.
Okay. Thank you.
All right, let's do why don't I have you try 66. In some ways, I think it's not as complicated as the one we just did.
Okay, so what I got was 4 cubed
That's
and
right.
you just
And what is 4 cubed?
you 64.
Yes. Okay, let's keep going here. 68 is kind of the question we ended up talking about last time. We a little bit of discussion today. Um, there could be a rewrite step here. Like you could look at it as, okay, it's 3 to the minus 4 times 1 over 1 to the minus 9. That's one way to do it.
Okay.
Or um, maybe you can do it another way. It doesn't really matter. Like you get preferences, you get choices here. You get to choose how you want to work it. Um, just see if this makes any sense from here. I don't want to say too much, maybe.
Okay. So would this just be 1 to the power of 9 over 3 to the power of 4?
Yes, exactly.
Okay.
So you like you have to when you see a problem like this, you have to literally be like, oh, okay, it's 1 to the 9, 3 to the fourth. Like anything that's negative flips, for lack of a better word, like moves to the bottom, moves to the top.
Yeah.
Okay. So then the 1 to the ninth is 1, 3 to the fourth is 81.
Okay.
Is that okay?
Yes.
So we did some examples like this last time where it was like neg x to the minus 2, y to the minus 3. What does this reduce to?
That is y3 over x2.
Good. Now I'm just going to very slightly adjust the previous example. Let's say there's a 6 there. What is the final answer?
Um, so you make it 6 times y3 over 2x.
I heard something kind of like this. Is that what you meant?
Oh, yeah, that's what I was gonna do.
Okay. So like the 6 is not impacted by any of this.
Yeah, it's just on the
Okay.
side.
It's just on the side. Okay. So we're gonna look at 70 now because 70, like there's a couple ways to look at 70. And there's when sometimes people get really distracted by things that they shouldn't be distracted by. All right. So let me show you one way to look at this problem. It's to break it up into the stuff that's in red and the stuff that's in blue. Okay. Now, if you just
Okay.
look at the blue, and this is what's hard, right? It's like you've gotta ignore the stuff that's distracting. That's the stuff
Okay.
in blue. What does it become?
The stuff in blue or red?
Well, blue, because rewrote it over here on the right.
Oh,
This
okay.
stuff, just the stuff in blue. I should have put it in blue. What does this become?
That becomes k7 over x9.
Good. This stuff in red is just distracting, but it comes with.
Okay.
Any questions on that?
No.
Okay,
So would that be your final answer?
that's it. There's nothing else to do.
Oh, okay.
I feel like there's still some confusion.
I feel like you would just put like a 21, like the 20 and then the one exponent and then the -1 exponent. And then you do
you
something like that.
you don't want to add you don't want to add exponents. They're just numbers. They're just numbers.
Okay.
All right, but we you said to 80, right? Up through 80,
82.
82. Okay, let's keep going here. I always want to make sure that I can make more comments later. So this one, when the bases are the same and you're dividing, you subtract the exponents. Subtract the exponents. Like it doesn't matter what they are, you just subtract them. Okay. So
Okay.
this becomes n 18 minus 6 which
That'd be
is
N12.
N12. Yeah. So the issue or the like where it becomes problematic, let me just look ahead here. Okay, we are going to see those. Where it becomes problematic is when you get negative exponents, but there are none here. Okay, so let's look at 74. 74. Okay. So again, like this has got a part that you need to focus on, which is the part in blue. You really just want to focus on this. K to the -4 over K to the 8th. So it's just like the last round. When the bases are the same, you subtract the exponents, okay? But you have to write it a certain way. You have to write the top number minus the bottom number.
Okay.
So this becomes K to what power?
That'd be -12. But you can't make it that, so it'd be
So, well, that's okay. Hang on. It's even when it's negative, you just keep it for now. So you're gonna write 24 K to the -12 power.
okay.
Okay. But then you're in your head, you're like, well, I can't have negative exponents, right? I got to do something with this.
Mm-hmm.
But it's just this K to the -12. That's what you're going to manipulate. What does that become? We did that earlier.
That becomes 1 over K12.
So 1 over K to the power of 12. Can you tell me the final result here?
That'd be 24 over K12.
Good. So even though it's got a negative exponent, don't try to like put it in the top or bottom. It always goes in the top. Just put it in
Yeah.
the top and then deal with it.
Mm-hmm.
Okay. All right. So 76 is the first problem where you have kind of some choices. So you have choices here. You can either simplify the top, which I would recommend, or you could take like this R squared and this R to the -7 and combine them.
Okay.
I would recommend working on the top. What
So
does the top?
combine both of those.
Yeah, what into one term? What so or into one base?
That'd be
So,
R to the 8th power.
yes, it's R to the 8th over R to the -7. So this again, where is really, really important. When you subtract, you have to show the subtraction 8 minus. Okay, 8 minus. Like I'm not accounting for this bottom number yet. It's 8 minus -7.
And that'd be R15.
R to the 15. Good. Good. Let me have you try another one like this.
Okay.
Let me know when you get all that down.
I got it down.
Okay. Let's go x to the 4th over x to the -2 times x to the -3. Go ahead and simplify this for me, please. And this time I would work on the bottom first.
Yeah. So I got X as my final answer.
Just x, just plain x,
Yes.
no exponent.
No.
Okay. Tell me what did you get from the bottom? What did it reduce to?
So I got -5.
Okay. So
And
this
then
is
I
correct.
flipped the 2. Oh, okay, go ahead.
Oh, so you flipped it. Okay, that's fine. So where did you put it?
So I put X5 over X4.
No, okay, no. So there's the problem. There's the problem. You
Okay.
this. Well, okay. Let me. This is very important because there's a couple of things you can do here. It's x to the 4th times 1 over x to the -5. So what you do to this right here has no impact on the 4
Okay.
if you're doing it that way, and that's fine. That's totally fine. So what I'm
Yeah.
trying to say is it becomes x to the fourth times x to the fifth.
Okay.
So that's option one. And then what does this become?
That becomes x4 over x5.
No, why you can't, you've got bases the same. Add the exponents.
Oh, okay. So that'd be
Like once the exponents are positive, you don't move them around anymore.
okay.
That's
So it'd
that's
be
kind of a
x.
guide. Okay, now here's what I was hoping you would do. I mean, what you did this way does work. But what I was hoping you do it would see that when you got to this line here, x to the fourth over x to the minus 5, that you would subtract 4
Yeah.
minus a minus 5.
Okay.
4 minus a minus 5.
So that'd just be the simpler way to do it.
Well, preferred way. I
Okay.
still sense that, yeah, like maybe it was because they had the same variable, but you only flip the negative one.
Yeah.
Okay, so let me yeah, let me keep going here. We got plenty of time to get through all the rest of this. So let's say it's y to the sixth over y to the minus 3. I want you to simplify that however you want. There's no right or wrong here. It's just what you see.
So you wouldn't flip them, you're saying?
Well, you could so there's two options. Option one, option two. So option one is y to the sixth times 1 over y to the minus 3. And this becomes y to the sixth times y to the power of 3,
Okay.
which becomes y to the power of 9. I don't
Okay.
do I don't do it I don't do it that way, but that way works. Like, and that, just because Matthew doesn't do it that way doesn't mean it's wrong. Like, I'm not
Okay.
the most, supreme chooser of exponent rules. Sorry. Okay. You get a choice here too. All right. Option two is you subtract 6 minus 3, but you have to remember it's minus. That fraction bar is a minus whatever's down on the bottom.
Okay.
Minus a minus 3, and that becomes
Why not?
y9. So if you want to know why I choose this one on the right, it's because it's less writing. I'm also very comfortable with subtracting
Okay, I get it
negatives,
now.
but they're the same. They're totally the same. Okay.
Yes.
All right. Be wary of people that are like, oh, this is the best way to do it. I mean, there's usually more than one way to get there. Okay, let's do 78. We kind of already did a prop. No, sorry, we've not done one like this. I was looking ahead at 80. So 78. So here's again, there's kind of a rewrite step here to sort of organize it. I'm going to add a 1 here in front. It's 1 over 100, a to the 11th, a to the 15th, b to the 7th, b to the 1st.
Yes.
Now notice all the exponents are positive. Do you agree with that?
Yes.
So you don't move them. There's no reason to move them. You're sort of forced into subtracting and subtracting. Do you know what I mean by that?
Yeah.
Okay. So this middle one is 11 minus 15. Next one on the right is 7 minus 1.
Okay.
Tell me what this becomes here. This middle
So
one.
there'd be a -4
Good.
and then b 6.
Good. Now it's still 1 over 100. And if you need to, you can write these over 1. Like, if that helps, like, really, that's okay. Until you get down
Okay.
to your final answer, you can do a lot of things here. That middle one is really standing out. It's like, what do we do
Yeah.
here? What do we do with that one?
So you want to make it a positive, so
Yes. That's
you
what
go 1 over a4.
good. like that.
Yes.
So in the top, you've got 1 times 1 times b to the 6th. So just b to the 6th over 100 a to the 4th.
Okay.
All right, let's go to 80. We actually already have done a couple like 80, but so I'll let you try this one on your own. We're kind of back in like the 60s, early 60s when I started showing you this, but just try this one on your own. Let me know what you come up with.
So I got 5 cubed over 4 cubed.
Is this your final answer? Like, would you put
No,
this? Okay,
you have to solve them.
keep going.
So 125 over 64.
Good, really good. All right, so 82, I'm going to show you a couple of ways. I'm going to show you the 2 different ways to do 82. And you're going to, like, if your teacher hasn't said this to you, like you get multiple paths on almost all these problems. Okay, so here's option 1. Okay, option 1 is I don't like the negative exponent, so I'm going to deal with that first. Okay,
Okay.
so that means we're going to flip what's inside z to the 6th, y to the 8th to the power of 2. Is that okay?
Yeah, let me just write down some notes
Okay.
for it.
All right, apologies. Yeah, just let me know when you're ready.
Okay, go ahead.
Okay. So the first option is I don't like the negative exponent, so I'm going to
Mhm.
flip what's inside and make it a positive exponent.
Mhm.
Then you distribute that power of 2 to both. So it's to each of these. Okay, so it's z to the 12th, y to the 16th. That's option 1.
Okay.
Option 2 is to distribute the negative exponent right away. So that's y to the 16th, negative 16, z to the negative 12.
And then you just flip them.
And they just flip them. Same
Okay.
answer,
Yeah.
but and this is kind of the break point in the lesson here. Everything else from here is a lot harder.
Okay.
So if you have time, like it would be good to redo maybe the odds, or I know you got tons of stuff to do, but my point is like you're going to start having multiple options and you have to be clear on which one and why. Like, why do you want to go down that path? Because it's up to you. It's totally up to you. There's not a right or a wrong.
Yeah.
But so, all right. So I'm going to stop the recording here.